Okay, all right. Do you guys know you're sitting in the most dangerous room in the high school? You are. Whether it's this chemistry room, the chemistry room next door, or the two chemistry rooms around the corner, these four are the most likely places for something to happen in the high school. In the past 15 years, there's been 6 or 7 evacuations of the building due to chemistry room issues. All right, so if something's going to happen in the school, it's going to probably happen, odds are it's going to happen in here. The most dangerous person to you in here is who? Maybe yourself, but there's someone even more dangerous. The person working next to you. Because if it's yourself, you're generally not going to spill things or break things on yourself, usually, right? But what are you going to do? You're going to throw it someplace else, or it's going to go someplace else. So I would normally say it's your lab partner, but I don't think we can have lab partners this year. So if there's somebody working in the near vicinity of you, that's the person who's the most dangerous person to you. Okay, the first section on here is acids. What's an acid? You guys know what an acid is? First we have to know what an acid is before we can talk about how you detect an acid and things like that. Do you guys know what acids are? Have you ever heard of acids before? Do you know what an acid might be? Can you think of any acid that you might have in your house? Citric acid. Citric acid. Do you have citric acid in your house? It's in the candy you like. What kind of candy is it in? It is. It's a sour taste, right? Citric acid. Where else can you find citric acid? You can find citric acid naturally. I wouldn't call candy natural. All right, natural food stuff in your house. You know where else you can find citric acid or any other acid? You guys don't know any other acid you might have in your house. How about orange juice? Is orange juice acidic or an acid? Yes. What acid does it have in it? Citric acid. All right. Soda is an acid. Soda is a big time acid. That's why it's bad for you to drink soda. All right. Obviously, there's the sugar part of it, but the acid part of it's really the negative thing. If you drink soda, anybody drink soda every day? Not me. I never drink soda. No. If you drink soda every day, it's better to drink it out of a straw and not in a bottle. Because if you drink it out of a straw, it doesn't coat your teeth. It just kind of goes down the tube, so to speak. All right. So acid. So we'll think of orange juice. We'll think of the very concentrated acid of orange juice. Have you ever spilled orange juice on you? We have to know how to detect if we have an acid on us. Like everything, like if I show you, is this an acid? Can you tell by looking at something if it's an acid or not? Can you tell? I will tell you that one of these two things is an acid. If you just look at the liquids, don't they look the same? Yeah. So you can't tell just by looking at something that's an acid. So how do we tell if something's an acid or not? If we want to be really specific, we use a pH meter. All right, you measure the pH. If it's less than 7, it's an acid. But I don't know if anybody has a pH meter at home. I don't have a pH meter at home. So how do we know if something's an acid that gets on us? What happens to us if we get acid on us? Yeah?
Your skin may start being irritated.
Irritated. There's something even simpler than that. Has anybody ever spilled orange juice on their hand or got it on their hand or anything? No? Huh? Yeah? Does it hurt? Have you ever put on a cut? You ever had a canker sore and drink orange juice? Like if you drink orange juice normally, does it bother, does it hurt or anything? If you have a little cut in your mouth or a canker sore, does it hurt? Yes. So that pain, that burning sensation, that's how you identify an acid. All right, acids are identified by warm burning sensations. So that's your first answer right there. Okay, you can type it. All right, detection for an acid is a warm burning sensation. All right, I'm going to show you what an acid can do. This is pretty strong acid. So up here, when you guys walk into a room, there's going to be all kinds of things a lot of times. All right, I'm going to talk about some terminology of things. Do you guys know what this is? This is not a beaker. This is a beaker. Do we know what this one is? This is different than a beaker.
Graduated cylinder.
Graduated cylinder. What do you use graduated cylinders for? You guys ever used one before?
Measuring liquids.
Measuring liquids. Very good. It's beakers really hold liquids. We really don't measure with beakers. There's markings on them, but they're not super accurate. What is this? What is this? Graduated cylinder. Thank you. Wow, good. What's this? You guys ever seen one of these before? This is a thermometer, or a thermometer. My mask keeps falling out. All right, it's a thermometer. So what are thermometers used for? Measure temperature. Do we know what this is? You ever seen one of these things? It's kind of a big one. Have you ever seen one of these before? Yes? Do you know what it is? This is called a test tube. Do you know what this thing is that's holding the test tube is called? Test tube holder. So test tube holder. You hold a test tube holder by the little circle at the end. If you hold it here, the test tube can fall out. That's what people get. So you hold it, you carry it like this in a test tube holder. What do you think this is? These are all things you're going to have to know. So in the homework, in the presentation on the slideshow, it's there. But what is this thing right here is a version of a test tube rack. It holds multiple test tubes. Let's see, what else have we shown you? Ooh, this you probably do not know the name of. This is called an evaporating dish. What do you use evaporating dishes to do? What's their name? Say it. They evaporate liquids. All right. Sometimes the liquid we don't want it to splatter out, so we put this over the top of evaporating dishes. These are called watch glasses. Why are they called watch glasses? Because you can see in them and see what's going on. All right. So you got an evaporating dish, you got a watch glass. Let's see, what else did we not cover? This one we didn't cover. Have you ever seen one of these things before? You have. You know what it's called? No. This is called an Erlenmeyer flask. All right, we use them in chemistry all the time because we can put one of these on them. What is this thing that we just put on them? What is that? Do you know what this is? These are called stoppers. All right, so it's a rubber stopper that goes on the top. A flask is just something that carries a liquid. A beaker is not really a flask, it's got a separate name. All right, but the flask carries liquid and we can cover it. So that's that. And then our last instrument that we're going to talk about today, second to last, this is called a scoopula. In chemistry, we use it for lots of things. We use it as a spoon, a stirrer, a knife, all right, a poking thing to break things apart. All right, have you guys ever seen one of these things before? These things are used to transfer liquids. These are called pipettes. All right, and this is a plastic pipette, this little bulb we can squeeze, and then you put it into a liquid and it'll suck liquid up into it, and then you can squeeze it out and push the liquid out. So I'm going to use this right now to transfer this stuff up here. So when you come into class, if you come into class, don't mess with this stuff up here because usually you're not going to know what it is, and it could be potentially harmful for you. So here, I'm going to take this stuff right here. This is called sulfuric acid. This is the second nastiest acid we have in the building. This stuff will eat through skin, bones, dissolved tissue, all kinds of fun stuff. All right, I would probably almost never give this to you in full strength form. All right, but I'm going to show you what happens when it is in full strength form. All right, so I'm going to take that sulfuric acid. I'm just going to use the pipette if I can. All right, so I just sucked up some sulfuric acid. I'm just going to put it, there's a paper towel down here. I'll show it to you in a second. Remember, this is nasty, nasty stuff, right? What's it doing to the paper towel? Does the paper towel, the sulfuric acid went right down the middle of the paper towel. Does that middle of the paper towel look normal? No, it's actually burning the paper towel. And look what it's doing to the paper towel. It actually breaks it apart, decomposes the tissue over here. All right, I'm just going to rinse this off so I can put it in the garbage. Alright, so that's that with the paper towel. Now, what do you think you'd do if you were to get an acid on you? Now, hopefully it's not this strong of an acid, but if you were to get an suggestions? Anybody awake? It's not that late in the day yet. What do you do if you get an acid on you?
Rinse it off.
Rinse it off. Where do you rinse it off? If you're in here, where do you rinse it off?
The sink.
There's sinks all around the room. I think there's 9 of them. And you're always never going to be too far from them. If you get an acid on you, I just put concentrated sulfuric acid on my hand. I just want, can you confirm that it's there? Alright. How do I know it's an acid?
Burning sensation.
Burning sensation. I have a warm burning sensation right now. What do I do? Rinse it off with water. Now, do I wipe it down in front of me? Notice it's turning color now, right? You see how it's changing color? So I'm going to walk carefully to the sink, and I'm going to rinse off my hand. Alright? I purposely took my time on that to show you. Do you have time if you get something on you? Yes. You don't have to freak out, oh my god, I got acid on me, what do I do? And you start wiping and running all over the place and fall and do other things. Alright? I had plenty of time to get to it. That's the second strongest acid we have in the building at the concentration that you'll never deal with. Did it do anything to my hands? I'll dry it and show you. Did it do anything to my hand? Alright, you can see a really light thing in here. It did peel off a couple layers. It's a chemical peel, if you guys have ever heard of such a thing. It's a chemical peel, but it didn't make any lasting effects on my hand. Alright, still had plenty of time to deal with it. Alright, so treatment, you're going to wash with water. If it's in your hand or your face, you're going to use the sink. Alright, you're going to flush with water or rinse with water in the sink. Now, remember I told you the most dangerous person is the person who's near you, correct? So let's say you're sitting at a lab bench, someone walks by and they tripped and they throw acid down the back of you. What do you do? So you got acid, so you got concentrated acid down the back of you. Shirt, pants, and such. What do we do? Suggestions. Looking around the room, you can't leave the room. Yeah.
Use the hose.
Use the hose. That's not a hose, that's a shower. That's our shower. But you do. Alright, so if you're in here and it gets on your clothes and it's enough to absorb into your clothes, first thing that has to happen is the clothes have to come off. Well, probably the first thing that has to happen is whoever else is in the room is out. Alright, if it's a guy, I'm staying. If it's a girl, I'm going to get Miss Phelps, who's next door. Alright, and then we're going to bring you somewhere near our chemical shower. This is considered to be our chemical shower. You called it a hose. It's a hose. Alright, do you think it puts more water out? Nope. And so I'm purposely doing it into the sink here, but we're going to literally hose you down. Alright, the problem we have is we don't have a drain here. Alright, so we're going to have lots of water here, and we'll deal with that later. That's a small Apple's thing. We'd rather have to clean up the liquid on the floor than deal with the chemical burns on the back side of you. So if you were to get some acid on the front or back of you, you have to remove the clothing and clean with water, or flush with water. Alright, this actually happened 15 years ago-ish, with a teacher, not even a student. A teacher was in the prep room, and they were using a bottle like this of acetic acid. You guys ever heard of acetic acid? Acetic acid is the acid that's in vinegar. You guys ever smell vinegar? Alright, vinegar's got a pretty unique smell, would you agree? Alright, vinegar is 5% acid, 95% water. The stuff that we have in a bottle like this is 100% acetic acid, so it's 20 times more concentrated than vinegar. She was working in the prep room, which is kind of around the corner, and she went to put it on the counter and she hit the countertop. Now, this bottle's got a little, if you look at it, it's kind of like dusty. Alright, it's got a rubber coating on it, so that if I were to whack this bottle against here, this thing would stay encased. The glass would break, but the stuff inside of it wouldn't fall out. And then we get these bottles now because this happened at that one point in time. She hit the bottom of the bottle on the counter, and then the bottom fell off and the acid went right down the front of her. Waist down, completely covered in acid. What does she got to do? You guys just learned. What do you got to do? Huh?
Use the hose.
Okay, before you use the hose.
I'll remove the clothing.
Remove the clothing. So she removed the clothing. The person who was teaching in this room smelled that acid within like 30 seconds. So she went out of this room, went across the hall, and went into the door. Well, the acid was on the floor right there. She slipped. Up, feet up, on her back, and slid down the hallway into the other teacher. So now you had one teacher with acid down the front of her, from the waist down the front of her, the other teacher with acid all over their backside. What does that new teacher now have to do? Remove the clothes, and there's a shower in there like that. Another teacher smelled it, because it's that bad, it's that pungent, it's that strong. Another teacher went, and this was his first year teaching, he went into the prep room and saw two people taking their clothes off and kind of saw what was going on and shut the door. He went and pulled a fire alarm. The building evacuated for 4 hours. The kids were out at the stadium. The kids sitting out at the stadium could smell vinegar out of the stadium. It was that strong out there. To get the building to come back into the building had to be cleared by the Onondaga County Hazardous Materials Team. So guys had to come in, or guys or girls, the people had to come in with rebreather suits on. Do you guys know what rebreather suits are? They're like, if you think of Monsters, Inc., and those guys and the whatever people, they come in whenever they find like the human stuff. They come in those suits. They walked into the prep room. They saw what happened. They asked what they did. So the teachers, in the meantime, the two teachers who were covered with acids, cleaned up, got different clothes or lab coats or whatever. There was two other chemistry teachers who went in. Because it was an acid, they took all the bases in the prep room and threw it on the acids. Acids and bases neutralize each other. So they basically made water, but they had a big mess to clean up. So was that an intentional thing? Did that teacher plan on doing it at that point in time? No shot. All right, but it happened, and it's something they had to deal with. All right, eyes. What do you do if you get acid or something in your eyes? Now we're going to use something to prevent getting stuff in our eyes. We're going to use these very stylish goggles. These are the goggles that they say that you have to wear according to New York State. So with your mask and goggles, you're pretty much covered. All right, these goggles prevent things from getting in your eyes, but let's say something does get into your eyes. What do you have to do? Once again, look around the room. Yeah.
Wash it in the yellow sink.
The yellow sink or the eye wash station. So you come over here and you turn it on. So it's got water that kind of comes out. Now what do you do with your eyes? Do your eyes have to be open or closed? Open. Have you ever tried to open your eyes when they're running water? It's not easy to do. How long do you have to rinse your eyes out for? What do you think? What do you think is the standard for rinsing your eyes out with water to get something in your eyes, like a chemical? What would be a reasonable amount of time? 30 seconds? 15 minutes. So you have to hold your head under that water with your eyes open for 15 minutes. That I have done with students. I have actually had to hold their head in the water with kind of peeling their eyelids open. Because as soon as the liquid gets on your eye and you close your eyelid, it goes all the way around your eyelid. Alright, if it's a chemical that's strong enough to burn it, we want to make sure that we get all of it out. So if you were to get a chemical in your eyes, you have to use the eye wash station for 15 minutes. That's for a chemical. If you have something in your eye, you don't have to do it for that long. But if it's a chemical that gets in there, and it's a chemical we're worried about, then you're flushing your eyes for 15 minutes. You can practice at home, take a shower, try to hold your eyes open for 15 minutes in the shower. Cold shower. That's cold water, that's not hot water. Alright? It's not a fun thing, so hopefully we don't have to do that. Okay, odors. Alright, we're going to have somebody identify this odor. Do we know how to smell things properly? Do you guys know how to smell things properly? Because I don't want you to come over here and stick your nose right over the hump, your nose right over this, because that's not good. So how do we smell things properly? Because there's going to be times throughout this year that you're going to have to smell things, so you have to identify things by the smell. How do you smell things? You guys have never smelled things in a science class before. Have you ever heard of the term waft? You have. That's the only place you'd ever hear it. So if this were open, so I'm going to open this up, all right, and I'm going to take my hand and I'm going to cup it like I'm cupping the air. Think of it like cupping water, and I'm going to cup the air and bring it to my nose. Notice I'm not bringing the bottle towards my nose. I'm just cupping the air, and I can smell it, even through my mask, I can smell this already. All right, so you're wafting carefully, that's the terminology. We need to identify this odor before we move on. Who wants to smell? You can expose your nose so you can do it if you want. Colin, you look like you want to identify this. Huh? You will, right? So waft carefully. You got it? You got the smell, right? Did you smell it? Do you know what it is?
I know I've smelled it before.
You know you smelled it before. Mr. Rocco is going to smell it. Waft carefully. You got to smell it? You don't have to smell it yet? Keep your hands closed. And like scoop the air towards you. Yeah. You got the smell though?
A little bit.
A little bit? Seliger?
I don't know what it is.
Did you smell it?
Yeah.
I can tell when you smell it because your eyes. No one's got it yet. Smells like that. Yeah, little bit maybe. No one. You don't know what it is? Smelling salts. Have you ever smelled smelling salts? It's ammonia. So like you say stinky feet, some people say it smells like a cat litter box. All right, because that's ammonia. All right, this is really strong ammonia. But you guys, I showed you how to. Now sometimes I'll just have people smell it without wafting it, and it does funny things to their eyes. So we don't do that. So how do you detect an odor? You waft carefully. All right, treatment for odors. This is at home or here or wherever. The terminology for treatment for a bad odor is to seek fresh air. All right, seek fresh air. Now that can be done in lots of different ways. You leave the area, you turn a fan on, you cover the material and leave the area, whatever. But the terminology is to seek fresh air. Okay. All right, organic solvents. Have you guys ever heard of things being organic? What's it mean to be organic in terms of chemistry? Must contain what? Organic substances must contain, huh? That's the biology term. All right, that's true. Biology must be. Organic substances are alive, or once alive. All right, organic substance in chemistry terminology means they contain the element carbon. So organic solvents must contain carbon. So just like you guys are right now, I've been talking for a while. Some of you are paying attention, some of you may not be paying attention. You kind of half listen. You're like, oh yeah, I got it, whatever. And you come up and you get this chemical. I told you had to get some of this chemical, and you pour it into this cup right here, and you start walking back to your seat. And what happened? Where'd the cup go? Huh? The chemical kind of ate through it, and I'm going to show you that we can dissolve this whole thing. Remember, what's this called again? You remember what this was called? You remember what this was called? This last thing? A beaker. This was called a scupula. So I'm going to take the scupula, I'm just going to put this stuff down into contact with it. And you'll see that it's not dissolving it. What it does is it makes this plastic, which is polystyrene, makes it very, very flexible. And styrofoam has lots of air in it, so what this is actually doing is it's removing the air from it and just making sure all the air is gone. And then this is what's left. Right here. This is the plastic that was left from making that styrofoam cup. Alright? The substance that I use to do this, and this is something you could run into at home, and we talk about this for things at home, that's why I say at home stuff is important as well. This is really plasticky. I can't really pass it around to you guys because you can't touch from one person to another. I used to be able to do that. Alright, but I want somebody to identify this smell. This has got another odor, so we're going to waft this carefully. Who wants to identify this one? Okay. You want to waft?
It smells like cool stuff.
Not cool stuff. You definitely probably have this in your house. Have you ever smelled it before?
Yeah.
Don't know what it is? There's no name on this one.
Oh, it smells like Sharpies.
Sharkies?
No,
This-
Sharpies.
Oh, Sharpies.
Smells like Sharpies.
A little bit. A little bit. This one's got a little bit of a sweeter smell. Now you got the Sharpie thing in your mind? This is acetone. You guys know what acetone is? Acetone, Sharpies is similar to it. That's a good analogy. Nail polish remover. Alright? So nail polish remover. So this is an organic solvent. Alright? It's a liquid that's got made of carbon. If you do the same thing with gas, do not put gasoline in these. It'll do the same thing. But gasoline, and this is what they used to make napalm. If you guys ever heard of napalm, they make those sticky substances that would catch on fire. They throw it at things and then light it on fire so it would stick. Alright, so don't put gasoline in the styrofoam containers at home. Just be careful with what you're doing in there. So organic solvents must contain carbon to dissolve many materials, so be careful. Maybe inhale. So if you get a headache, you can leave the room, as long as I know. So headache means leave. Inhale means to breathe in. So if you breathe it in, if you inhale it, headache means leave. Maybe absorb through your skin. Alright, maybe absorb through your skin. So what that means is we can't eat during lab. No eating during lab. It's kind of like gasoline gas.
What was the dissolve many materials? So
Be careful. How do people like the smell of gasoline? Like organic solvent, you love it. So does everybody else hate the smell of gasoline? It's usually one or the other. It's usually not I can deal with it. All right. Many of the organic solvents have a smell. All right, good or bad. Some people like the smell. Some people dislike the smells. Some people are more sensitive than others. So organic solvents may be ingested. So no eating in the lab as well. So you're going to have two answers that say no eating in the lab. Alright, so heat is a problem. Is heat good or bad? In general, heat. Depends. It really does depend. It depends on if you want the heat or don't want the heat. If you expect it or don't expect it, that's usually the thing. So heat's a problem when it's not expected. Alright, and I'm going to show you some things back here. Some stuff set up. Once again, some more equipment review before we get going. Alright, this is something you've probably never seen before, and definitely don't know the name of this thing. This thing's called a ring stand. Alright, it's a stand that holds a ring. What does a ring look like? This is a ring. This is an iron ring. Does that make sense that it's an iron ring? Alright, and iron rings have this little clamp part on the back, and they will go on the back of the ring stand. So they go just like this. Okay? Now, depending on what things we use this to set stuff on, all right? Depending on the size of it, you might be able to set it right on there. It's not really the safest thing to do that, but you can. We will use these pieces of wire mesh. It's called wire gauze, and we'll set it on there. Now it's a pretty stable spot to set some things on here. Okay? All right. I'm just going to go over this terminology before we get going. This thing right here. What's this thing? Test tube. Yes. Remember we had the big one up front. What's this? Stopper. Very good. This is new. What's this one? Now I'll help you out because this was on here. This is called a test tube, right? This is called, ooh, didn't put it tight Now, did I tell you, I told you what this was called, right? Did I tell you this one? What's this one called? Test tube holder. This one is a test tube clamp. What makes it a clamp? Because you can clamp down, okay? And I'll talk about what we're going to use this for in a minute. All right, and then what's this called? A beaker. All right. Have you ever seen one of these guys before? No? All right, this is called a Bunsen burner. And this is for us, this is our primary heat source. All right, we will use hot plates at times, but lots of times we use Bunsen burners. There we go. All right, Bunsen burner is lit. Can you see the blue flame? Can you see the blue flame? I don't want to put the paper any closer. See how it's got a blue flame? That's due to the fuel. This is methane or natural gas. All right, so we use this to heat things. Can you see that there's two cones? Can you see like an outer cone and an inner cone? All right, the hottest part of the flame, and I'm going to stick this back in here, is the tip of the inner cone, right in there. All right, not down here. All right, it will get caught down there, but not as well. And way up here, not really the hottest part of the flame. So we're going to use this to heat up some water in the beaker. All right, we said heat's a problem when it's not expected. All right, I will tell you, by and large, the majority of accidents in the lab happen in the last 10 minutes of class. Why? Why would the majority of accidents in the lab happen in the last 10 minutes?
Because people are rushed to finish.
People are rushing to finish. Exactly. They want to get to lunch, they want to get to the next class, they want to do whatever. All right? So, rushing is a problem. The other thing is a problem is if you were to work with a lab partner, one person does a lot of the work and doesn't let the other person do anything, or the other person doesn't want to do anything, depending on how the scenario is. All right, so here what we have going on is we got this heating up the liquid in the beaker. This is the beaker right here. Can you see that the beaker is getting warmer because you can see the condensation of the water? This is just water inside of here. The water inside of the beaker. All right, so that's heating up, and I'm trying to get it to kind of start to bubble here. All right, but I'm going to go back to